All right, welcome to class assignment number 9. We're going to draw a cone in this one. So we're going to draw, which another name for a cone is just a round taper. It is a transition, and it's going to go from uh, a base diameter up to kind of a top diameter. Concentric means the top diameter is going to line up on center with the base diameter, so their center lines will line up. It'll be like an equal taper. So yeah, and I'm going to be working with these dimensions that I have up on the screen. So looks like the base is going to be my large diameter. I'm just going to draw this kind of in proportion with the base being bigger, and I've got it at 6.65 inches, which is kind of matching 6-inch schedule whatever pipe. Like that matches like the OD of 6-inch pipe. And I've got a small diameter that's 3.5 inches, which is kind of matching an OD dimension of 3-inch pipe. I haven't really specified a schedule or whatever, so. And I've got an elevation of 8. So with those measurements, let's go over to AutoCAD here. And I'll just draw this one along so you can follow along with me. I'm going to start by just kind of drawing some reference information here. I'm going to pull up a dashed line and let's see here. I just want to go. There's my direction, same information up on screen right here. So the first one is 6 and I'm going to start at the base, 6 and 5/8 here. So I'm just going to draw it over to the side of my instructions here, and I'm going to draw this diameter of 6 and 5/8. I'm going to do diameter 6 and 5/8 there. I can kind of, that's just a reference circle for the diameter of the base. I'm actually just going to draw a front view of this, so I'm going to kind of interpret into this front view. I only actually need like one view of this particular drawing. I've kind of saved the easiest for last. And the one thing I didn't mention yet is that this is a radial line development type of drawing. And maybe it's the first one that we've done so far that would be classified as a radial line development drawing. So yeah, like I could draw a top view, but it would just be like a circle inside a circle looking. And so I'm going to actually draw a front view. So this is what I've just done is I've got a reference circle up. I'm going to probably trim this and develop this out like I normally do. So this is the base of my cone, showing the diameter. And now I'm just going to go ahead and like put in the elevation of 8 inches. So this thing is going to be 8 inches tall. And then I think I'm going to do a development circle here for the top, which is 3.5 inches in diameter. So I've got my two circles, and maybe I could kind of draw in the top. Yeah, just like that. So I'm gonna initially draw some reference lines here. So I'm gonna connect the outsides of my cone from the base diameter here up to the top diameter. So this is kind of a front view of the cone. I'm just gonna do this with some reference circles first, or some reference dashed lines. I'll show you why here. I'm gonna put that in. So that's just kind of ghosted in my outside edges of my cone. So far these are just development circles. This is the left-hand side of my cone. Right-hand side of my cone, left-hand side of my cone, top of my cone right here, and bottom of my cone. I'll trim this out so it'll kind of look, right here. You might find that I don't need this. I'll just add a few layers here just to get rid of some stuff. Yeah, you might find I don't need this one. I'm going to push it to another layer just to get it out of my drawing space. I just needed it to put in the top. And to put in the top diameter there. So I'm going to get rid of that one. I'm just going to use, to develop this out, which is kind of unnecessary, honestly, but if I was going to develop one out, it's going to be this one. I'm going to trim it. Maybe I'll just trim this right now. And get this one out of my space. So now I've got my development circle down on the bottom here that I can take some node points up and over. But what I want here, which is kind of unique to this drawing, is I need to know like this point out in space where if these sides were to continue on the right and left side of this thing, if they were just to continue on without stopping, where would they cross each other at? And it's going to define a point that I'm going to call an apex point. So I'm kind of looking for, it's going to, because they're concentric, meaning the centers line up, the bottom diameter and the top diameter centers line up, where those two cross each other are going to cross at the center line of this fitting. And so what I'm going to do that, I drew these as lines. They're easy to lengthen that way. I just hover over, I grip the end, I kind of say lengthen. You know, this is kind of why I've drawn with lines a lot, but I'm kind of just looking to guess, like, how far does this need to be to where it looks like it crosses center line. I'm kind of looking at the readout of how long my line is. You know, 16 inches looks like it's crossing pretty good. So I just put in 16, and then I've just lengthened my side. It stayed connected, so it's like still passing through the outside edge of the top diameter and the bottom diameter, and I've just pulled it arbitrarily long so that it crosses the center point here. So I'm gonna do the same thing here on this one. I'm gonna lengthen it in that direction. Like I'll just do it 16 inches too. You can see that's plenty. They cross and make this little teepee looking structure here. This is the point I'm looking for. It's called the apex. And maybe I'll pull this line up to the apex now that I've kind of defined this line. I'm going to bring my center lines and my two sides to a common point there. I can leave these long right now. Sometimes I like to leave those long, or I could tuck them, but I'll just tuck them. That bugs me now that I say it. So like now I can actually, now that I've defined what that height is, this apex point, you know, they all have this in common, so I can just go ahead and tuck them in to where they actually cross. So now, yeah, I've got this like, and all this up here above my top, this is the top diameter. This is as far as my actual fitting goes. All of that, I think my mouse just died on me. So, totally. I'm going to push pop. All right, I should be back here. I had my mouse just die on me, so. Yeah, so I've pulled these up to this apex point, which is really critical. All this stuff above my top solid line here is just kind of reference space only. So now what I can do is just kind of like lock in, you know, the sides of this thing. I'm actually just going to draw over my reference line there that I used to find the apex. Kind of just block this in as a solid line here. So yeah, cool. This is ready to actually develop now. These developments are pretty quick. So what I'm looking to do now is I use this point as kind of a center of an arc. And what I want to establish is I want to pull, and actually have a finished drawing here. Let's see what color system I used when I did this. Yeah, I actually just pulled some. This is kind of where I'm headed here. Got my apex point, and then I kind of developed the node points here, which maybe that's a little redundant information. I might not even use that. I do want to know the node spacings, and so I'm gonna draw it just slightly different here. But what I'm looking to do is kind of draw these magenta lines. So I've just kind of seen what color-coded system I used here. It doesn't really matter, but I want some reference circles with my apex as center. I want one that is out here to the longest part of my cone, which is right there. So, and then I want a secondary one with the apex as center right here to where the my cone kind of ends, and so I'm kind of staying to this right side and using it as the points, which they pass through the left side of this too. So now I've just got this like, you know, this essentially 360 degrees of kind of development area. So this is what I've defined as my cone kind of fits in this area between these two circles that I just established off the apex. So, but now it's not that whole circle, obviously. It's just a portion of that. And so what I like to do now is just kind of establish a starting point to start off the apex here. I just want to pull kind of an arbitrary point out here. It looks like I've got something snapping to a degree that's probably on my grips or whatever. That's fine. I'm just looking. That's no particular degree. I'm just looking for like a straight line here, and this space in between these two now is not going to be used between my actual drawing, which I could join as a polyline real quick, like this. Anyway, let me just see if I can do like a quick polyline edit, just so when I do want to turn that into a polyline. I'm going to join it. I'm just actually making this so that when I highlight this, it kind of shows it. This is my cone, the front view of my cone. So yeah, that all pops now when I highlight it. So there's my cone, front view of my cone. That's 6 5/8 on the base and 3.5 inches on the top. And I'm actually kind of looking at a true length here. When I'm looking at the sides of a cone, I see like a true length on the side. That actually does pick up that actual dimension. So the distance between these two is the same that I just established off this white line. So this gives me a place to start my pattern right here. And now what I do is I need to find like how far down this pattern I need to go. And it's just essentially the circumference of 6.625 inches here. And then the circumference of 3.5 inches will find itself if I just take this pattern back to the apex point. So essentially what I need to do is like from this little arbitrary line that I established here, this white line where it crosses this big arc segment here, I just need to like step off this, from that point just step off a distance equal to the circumference of 6 5/8, and then bring that line back to the apex point, and that's kind of the end of my pattern. Like it'll lock in the circumference of 3.5 inches just based on how I pulled the arcs off the apex. So real simple. Like to, you know, I could do that with I'll show you a little like compass trick, which we've used a little bit of anyway, but I could do that mathematically and actually measure out that distance across, you know, just figure out what that circumference would be, 6.625 times pi, and it would spit me out a number that I could drag across here, unless I was working with material that I'd need to be aware of, some deductions for material allowances. But what I can do here is like what we've done, kind of a quick little hack way to do this, is if I just take my reference circle right here, divide it by 6 like we normally do, it establishes those node points, which I could totally just kind of draw in. I'm just not going to draw them up I don't really need them up for this particular object. I don't really need them like up the distance of my cone necessarily. The interesting thing is, if I bring them up here like 90 degrees like I'm doing right now, taking the node points like we've done in the past up to where the object actually starts. So here I come, pull all these up. One more. Make sure I'm actually getting to the object and not just the magenta colored line. Looks like I did good. Yeah, so what I could essentially do, the reason why I'm not going to take these across the object is because where they hit this point, if I were just to project these from where I stopped them up to the apex, they would pass through the node points up here. If I would have left that development circle on up here and drawn those straight down to the top of the circle, they're going to pass through the same. They're going to pass through the same points. It's concentric. That's just how that works out when my center lines line up. So what I really need here is just like, maybe I'll just use like an orange or something. What what I really need is kind of just a quick hack way to get the circumference of that 6 1/4 or 6 5/8 circumference. Is I just pulled a circle that's just equal to one of these, the distance between these node points, which is slightly under the size. But I just need 12 of these circles along the outside perimeter of this to be the circumference, roughly. And that's kind of a hack way, a real quick way to do it with like a compass and do it by hand. And so that's what I'm going to do. We haven't done a lot of this, but it is a way to like quickly step off a circumference. So I'm going to copy this thing from its center point. And I essentially need like 12 of these to go all the way around, right? Like it's just 12 of these in between my node points. There's 12 node points around a whole circle. So and so it's just 12 radiuses, which they can get a little bit confusing here. So I'm going to use this is the starting point of my pattern that I decided. So that's like 1 radius, and then there's 2, and I kind of count these as I go across. There's 3 and 4, 5, and 6. This is a great place to like stop for me and break out my pattern just a little bit. Like I've kind of done half my pattern. There's 6. Those are 6 radiuses of that circle, which should be 6 node points. 1, 2, 3, 4, 5, 6. Yeah, this is a great place for me to like drop in just a quick reference line that this is the center line of my pattern. I'll just take it back to the apex also. And so I've just done half the pattern. I'm going to do 6 more of these. So that's where I finished it off at the last one. So I'm going to pick it up and start it back on my center line. There's 1, 2. Make sure I get this here. 1, 2, 3, 4, 5, 6. Got it. That should be the end of my pattern. That should be 6. That should equal my 12 node points. So I just take that line and I'll make it white to finish my pattern there. So now this back to the apex equals a cone. Simple as that. Now let me just like highlight where the cone is here. I'll do it my standard like red. So here's my cone. I'm going to actually do this as like a polyline now. And you'll see why here. So the actual pattern I just developed actually is here. This is where I kind of started, but it only goes to here. This is like where the top of my cone would be. And then I'm going to like arc this and second point it. And I'm going to use my center line as a second point. So I'm just going to that's my second point. And this is where my pattern finishes. So essentially that equals the circumference of a 3.5 inch. And I'm going to go back to a line here. Yeah, that what I just drew there, that little polyline equals the circumference of a 3.5 inch round. And then back to here. And then arc and second point back to this center line here. And finish off right there. All right. So that's it. That's like the pattern. Now I can actually just like copy that out. That should be one piece. Yeah. And you might see me take that. Sorry, I want to actually take more than that. I want to take my pattern out. And probably the center line. I want to copy that, and I'll tuck it when I get it out there. So I'm going to copy it by this point. Drag it over. And drop it. And you'll see me. This doesn't need to be this long. Like I can tuck this back in where it's perpendicular there. And that's just a reference line. You know, if I were to cut this out on the plasma, all I need is the cone, and you know, I could argue that I maybe would want to know where the quarter mark is here too, like 1, 2, 3 and a quarter mark, 1, 2, 3 and a half line, another 3 and then a quarter mark. So I could actually have like some additional lines in here that would be like the quarter of this. But that is, if I were to roll this around now, in a roll different than we have, it would have to be a roll that could be tight on one end, tighter on one end than the other, and be able to do this diameter, this is a small diameter for the equipment we have in our shop. But that 3.5 inches is what would not work in our shop on our current roll. But if I could, if this was bigger, I could actually roll this in a roll, and it would finish off, you know, at 3.5 inches on top and 6 5/8 on bottom. Now, I could do this on a press brake too. I just have to do it in halves. Like instead of this being, I could actually like draw this as a cut line, divide this pattern in half. Then I could actually step brake it in the step brake, or in the press brake, or in the leaf brake even, and kind of just break these round in halves for small diameter cones, which is something you need to see in the shop to be able to understand that. But I have some options on how I form up something like this, and I could actually do that on our press brake here with even these diameters. So, but that's it. That's the cone, and we'll do another one like assignment 10. I'm going to push the cone. That's going to be it's going to be all pushed to one side, so it'll be flat on one side, an eccentric cone. And kind of flush to one side. So that'll be my last assignment for this block of class, and that would be class assignment. This was just class assignment 9. That one will be class assignment 10. So that one, stay tuned for that one.